So we have an interesting property here, which is that warp is equivalent to the compensated law of demand in situations where we have a compensated price change. So if the Walrasian demand function is homogeneous of degree 0, and if it satisfies Walras law, remember these are the assumptions, then the Walrasian demand function satisfies warp only if compensated law of demand is met in situations where we have a compensated price change. Compensated law of demand is the idea that prices and demand move in opposite directions. So if we take the product of the change in price and change in demand, that product must be negative or equal to 0 if the two bundles are the same. Let's illustrate this result. Consider a situation where we have two commodities, x1 and x2. And our starting point is a price-wealth pair PW. So maybe we have this budget set here. And the Walrasian demand function is X. This is the bundle which is observed to be chosen. Let's now assume that price is changed to P prime. Well, compensated price change is the idea that the wealth is also adjusted to W prime such that the old bundle must remain exactly affordable under the new price system. So W prime is exactly equal to the cost of the new bundle, the cost of the old bundle at new prices. So let's assume, for example, that the price of the first commodity decreases. So maybe we have a new budget set like this. But wealth is adjusted such that the old bundle remains exactly affordable. So our new budget set is something like this. The slope is given by P prime. But the wealth has been adjusted such that the old bundle remain exactly affordable. If warp is met, then compensated law of demand must be met, meaning prices and demand move in opposite direction. If the price of the first commodity went down, the demand for the first commodity must go up. So the new bundle that we must observe to be chosen has to be somewhere in this area here. We cannot have a bundle being chosen from the new budget set that would be here because that would show that the demand for the first commodity is going down. So for example, new bundle maybe is here. And this is X, P prime, and W prime. This is what this interesting property is giving us, this result. Now, why is this interesting? Well, in a way, it gives us a possibility for falsifying warp. If we limit ourselves to situations where we have compensated price changes, if warp is met, then we must always observe price and demand moving in opposite direction. So if we observe one instance, and we only need one observation to falsify warp, one observation where it is not the case that price and demand are moving in opposite direction, in other words, they're moving in the same direction, then we have falsified warp. So that's the interesting conclusion here, is that this result, this property here of warp being equivalent to compensated law of demand in situation of compensated price changes, it is giving us a way of falsifying warp. Again, all we have to do is consider situations where we have compensated price changes, and if we can identify one instance where price and demand are moving in the same direction, then we have falsified warp. So let's do a couple examples just to make this crystal clear. They're both taken from the textbook, Maskell, Winston, and Green, on page 30. The first example is a situation where we do not have a compensated price change. We are moving from P prime, W prime to P double prime and W double prime. Here is the old budget set from which we are choosing this bundle. Here is the new budget set from which we are choosing this new bundle. The old bundle is not exactly affordable at new prices. If it were, it would lie right here, but it's not. However, it is affordable, and so we have the new bundle being revealed preferred to the old bundle. The cost of the old bundle at new prices is actually less than W double prime, so the old bundle is affordable when the new bundle is chosen. And you'll note that this is not an equality sign here because we do not have a compensated price change. And warp is met to the extent that when the first bundle was chosen from the original budget set, we can see that the second bundle clearly lies outside of the initial budget set. So the original bundle is not revealed preferred at this point. So we can write that the cost of the old bundle, the new bundle at old prices actually exceeds the wealth of the consumer when the first bundle was chosen. So warp is met. The second example is a situation where we have a compensated price change. We're moving from, let's say we're moving from P double prime, W double prime to P prime, W prime. So here's our old budget set. Here is the initial bundle. Here is our new budget set. Here is our new bundle being chosen. We can see that the original bundle is exactly affordable under the new price system. Now, the price of the first commodity actually went down, since under the new budget we can afford more of it, so prices went down, but the demand for the first commodity also went down. So compensated law of demand is violated because price and demand move in the same direction in this example. So warp is violated. Another way to think about this is to simply say that the original bundle is affordable when when the new bundle is chosen. So at new prices, our original bundle here is affordable. In fact, it's just affordable, just affordable, because we have a compensated price change, and warp is violated here to the extent that the new bundle is affordable in the old budget set. So using old prices, our new bundle here is actually affordable. So we have a violation of warp. Another way to think about this graphically is to say that in order for the compensated law of demand to be met, in order for the new bundle to lie somewhere on this line, that this requirement is actually equivalent to the new bundle lying outside of the original budget set right here. So compensated law of demand forces us to have our new bundle lie outside of the original budget set, which is another way of thinking of the compensated law of demand in this situation. So let's derive the proof for the statement that warp is equivalent to the compensated law of demand for any compensated price change. So we are considering two bundles. The first bundle is what was chosen at prices P and wealth W. The second bundle is what is chosen at prices P prime and wealth W prime. And the first thing that we can write is that we have a compensated price change. So W prime is equal to P prime times X in PW, meaning that the original bundle X, chosen at prices P and wealth W, is affordable, just affordable when the price system changes to P prime. So that's just the compensated price change. Now the second thing that we can write here is Valra's law. For the new bundle at P prime and W prime, we have W prime is equal to P prime times the new bundle. So that's just Valra's law. And subtracting one from the other, we get to one equation from the other. We can write that P prime times X P prime W prime less the original bundle is equal to 0. And this is our first equation. Now we can observe here that to the extent that we have a compensated price change, the first bundle is affordable when the second bundle is chosen. In fact, it's exactly affordable because the wealth is adjusted in that way. So the weak axiom of revealed preference requires that the second bundle not be affordable when the first bundle was chosen. Otherwise, we would have the first bundle be revealed preferred to the second bundle, which is not allowed under warp. So we can simply write that the second bundle must not be affordable when the first bundle is chosen, so the cost of the second bundle must strictly exceed W. That's just warp. Another thing that we can write, which is pretty straightforward, is Valra's law for the first bundle. We have two equations. We can simply subtract the second equation from the first equation. And that must be strictly positive. To make things easier, let's just multiply this by -1. And the inequality reverses. So this is strictly negative, and this is our second equation. And if we just take our first equation and add that to our second equation, we get the compensated law of demand. So this is strictly negative, but we allow for the possibility that the two bundles be the same. So if we allow let me just say that the strict inequality holds if the two bundles are different. But if we allow for the possibility that the two bundles are the same, then we can have the weak inequality. And this concludes our proof.